I'm proud of Randy. I want to say he and I have worked for 5 years, and we've trained students in wheelchairs to climb trees, collect and identify water bears. This was a federally funded grant program, but we were the first group of scientists to take kids with mobility limitations in the field. And Randy said if he can do it, they can do it. He was always very humorous. Go Randy, can you get it? Oh, we need AV again. Okay, ready to roll.
Oh, it doesn't look that way on here.
It's a funny screen.
I was sure glad to get invited to come out and hunt for water bears. And when I looked in the literature, I found out there are no records. So the 11 species we found are the first Malaysian water bears. And they fill a hole in our distribution patterns of the world. So thank you for having us and adding to world information. I could launch into a lecture trying to explain what water bears are, but simply they're a microscopic, 0.5 millimeter invertebrate animal that lives in moss and lichen. That's enough. They look something like this, although there's many different shapes and sizes. We've got 1,200 species described, and we think a new one from here. Let's see if this will change now. There we go. We're a very neat group of animals. We only have, we're a phylum, if you know what that is, and we only have 2 classes. We've got 4 orders and very few families. We're very, very simple compared with the bird folks and the insect folks and all these other groups, which makes it very logical. But when we get to 1,200 species, we run out of characters to separate them, so we have to get down to measuring things. So you may or may not be able to actually see that some of these things are different. I'm just going to go through the species we found and try and point out a bit about why they're different. We use the mouth parts, that structure up there, to tell them apart. And this one has 2 macroplacoids, large placoids, which are those dots up there. It has no micro, so there's no little one behind it, okay? And it has a narrow buccal tube or throat. So those are the sorts of things. We also use claws and cuticles and all sorts of other things to separate them. The second macrobiota species has 3 of those placoids, a microplacoid in there, and the buccal tube is a bit wider. And we measure that with a micron measurement. This one has, the placoids are now elongated. They're not circular. It has the micro, and the buccal tube is still the same. Okay? And you can see that maybe we're nitpicky. But these things exist in populations, and they reproduce their own kind. And that's our definition of species, okay? And they're not found everywhere. Some are, but not everyone. But we don't know enough yet to totally understand the distribution. There's a theory out that everything small is everywhere, and everything big is somewhere, but not everywhere. Tardigrades are sort of in that in-between land where we have some of both. Again, a very wide buccal tube, getting much, much wider here as we look through these. And in this case, they get smaller and other structures change, so we've given this guy a new genus. He's totally separatable from the previous ones you've seen. And then they do start to change. Here the placoids have gotten really long and thin. The buccal tube is very straight, but part of it is flexible. It looks like a hose, and I've actually seen some of these that turn 360-degree loops inside the animal. Here's one that has that super long buccal tube. It's only about 3 microns across, and about the only thing it can eat is a bacteria on end, sliding in there to to be eaten. This is the T-Rex of tardigrades. It actually gets to 2 millimeters in size, seldom, okay? It has none of those placoid things. It lost them. But it has this extremely wide buccal tube, and it's a carnivore. It eats nematodes, rotifers, other tardigrades, and any plant that it wants. It plows through the micro world sort of unobstructed. But did we find a new species? This is the animal we think we found. It's bright yellow, slightly orangish in color. It has beautiful plates across its back, and it has some spines coming off the caudal end that do not fit the pattern of any documented species I can find. So that's the schematic approach, where the dark are the spines that we're counting. It's that one circled that's really a point or a little hook that sticks off that mid-shaped plate that makes it different. I can find dozens of species where we have a long filament in that position, or where we have a really hefty sword-like spike, but none that have a point. Okay? And that's just one of 4 or 5 characters that we'll use to define this new animal. Okay? And these are very good pictures, thanks to the university for giving me an afternoon with a phase contrast microscope. And we will get more, we have more specimens. But our fingers crossed that this will be a new species here. And we actually found it at base camp. It's from a tree right on the walkway. So it is truly a habitat animal. We did find a couple of other unique things. One, we found eggs. And tardigrade eggs are quite spectacular, looking like Christmas tree ornaments or baubles of some nature. And we just happened, out of the first 4 that we mounted on slides, to catch one emerging from the egg. And I told Alan that in 50 years, I've only seen this 4 or 5 times in my life. So that's kind of a spectacular discovery. This is not the new species, this is another one, okay? The other thing we got was evidence of carnivory in an animal that I would not have thought was carnivorous. Over there is a rotifer, and in the gut of the tardigrade, we can see part of the rotifer's mouth parts, which is the kind of evidence, if you eat it and it's still showing in your stomach, you can't deny it. So that's what we've got. And we'll say thank you to everybody, and hope you've enjoyed tardigrades. We've sure enjoyed it.